Alright everybody, today we're talking about covering problems. Just a quick word of introduction before we get into those. There are different kinds of covering problems. The one that are most popular within geography and optimization, spatial optimization, are the set covering problem, the maximum covering location problem, and the backup covering problem. And there are a couple of others here that I'm thinking about, like the probabilistic coverage, the expected coverage, but generally we stick to those three at least for the moment. The set covering problem, the first one, is trying to minimize the number of facilities. So facilities can be post office, it could be emergency service, and so on, so that the population is covered. Population being individuals aggregated or not. The maximum covering location problem is trying to maximize that population that is covered. While the backup covering problem is quite interesting when you want to have multiple facilities that cover you, right? And as we will see, this is quite relevant in geography as well. So let's just focus a little bit here on an example, a pretty schematic example. I have a geographic region here, so it could be a county, for instance, right, or maybe a state. And what I also have are these dots here. They represent what we call demand nodes. So what are demand nodes, right? So if you had, for instance, let's say this was a census tract, right, or census block groups. This could be, right, and there could be more than those. This could be the centroid, the center of that geographic unit. Okay. Now, for the simplicity, I just keep all these dots the same size, but of course we can also think that there could be more people, let's say, living here than living there. For instance, you could have 95 people here, and then maybe 5 here, and so on and so forth. Okay. The second thing I've drawn, and those are the crosses. Those are potential facility locations, right? And typically what we are going to do is that we're going to assume a certain radius or a zone of attraction, if you wish, a catchment area. There are different words. I used here the word radius because I'm thinking about something that looks like a circle. But of course, if you were looking at travel time, this could have a different shape that's not a circle, but maybe it looks more like an elongated shape depending on what the road network may look like. So here I have these two facilities, and if I draw a radius around this one here, so let's call this one A, okay, around A, I see that I can cover 1, 2, 3 demand nodes. Aggregated or not, that's not the point, but they can be covered. While if I look at the red one here, I see that I can cover 1, 2, 3, and 4. So in this case, we can see that this facility, the one in red, is probably better, or is more strategic if we were to open it and decide as a 1 in our model.